As recent results from DeepMind's GPT-2 have shown, natural language generation models are increasingly capable of producing human-like utterances. But how do we systematically assess these models? Existing methods include n-gram overlap, which depends directly on generated tokens but ignores their meaning. Second is human ratings, which are effective but costly. Third is trained models to predict human ratings, but these still depend on external evaluation. To address some of these concerns, we propose an evaluation model based on the pragmatic notion that a good utterance allows a listener to achieve some communicative goal. Specifically, we worked with the color captioning problem using the colors in context dataset. It consists of reference games between pairs of participants, speakers and listeners. The speaker's goal is to describe a target color from a set of 3 colors, which the listener then tries to identify. Here the speaker describes the target as the purplish blue, which the listener successfully selects. The games span 3 conditions: far, split, and close, depending on the diversity of the color options. We develop a performance metric for speakers in the dataset, and then implement several caption evaluation models to find the one that correlates best with the speaker performance score.
Across all models, we featurize colors using a Fourier transform as described by Monroe et al. Each model is given a caption and a color input, and outputs a score representing the quality of the caption. We now explain the evaluation models. First, we implement a 2-layer colors-only baseline network, which ignores the caption and uses only the color inputs. Second, we implement a literal listener based on Monroe et al. 2017. It encodes the caption using an LSTM and predicts a Gaussian distribution over colors. Third, we implement an imaginative listener, which ignores the target color and attempts to predict it directly. It encodes the caption in the 2 distractor colors, concatenates the 2 outputs, and then predicts an output in color space. The model scores the distance between its prediction and the target color. Finally, we implement a pragmatic listener, which models recursive reasoning between a hypothetical speaker and listener. We sample literal listener predictions given plausible captions generated by a literal speaker, as done by Monroe et al. The literal speaker encodes a color prompt and generates a caption for the target color. The pragmatic listener performs Bayesian inference to determine a context-relevant color prediction.
To evaluate our model's performance, we introduce the Gaussian True Score, a speaker performance metric based on the rate of correct target identification by listeners in our dataset. This score attempts to measure speaker accuracy and efficiency. Higher scores are roughly proportional to correct target identification by listeners, and inversely proportional to speaker verbosity and the time it takes the listener to process their utterance. The performance metric correlation for a given speaker model is the Pearson correlation between the Gaussian true scores and the model scores, which are the model's average target identification accuracies. Here are the Pearson correlations for each of our models with the Gaussian true scores for each of the close, split, and far conditions and in aggregate. We also plot the model scores against the Gaussian true scores for each condition to visualize their correlation patterns. As expected, the close and split conditions have lower correlations than the far condition. In addition, the pragmatic listener edges out the literal listener, which performs better than the imaginative listener. This makes sense, since the imaginative listener tackles a fill-in-the-blank as opposed to a multiple-choice task. We envision multiple ways to extend this work. In terms of color captioning, there is room to explore better baseline models, performance metrics, and more advanced pragmatic reasoning models. In the bigger picture, we're interested in extending this framework to non-contextual settings and other grounded language tasks, such as image caption evaluation.